So in this video we'll be looking at SEC 2012 Leaving Cert Higher Level Paper 2 Question 2. It's coordinate geometry, the circle question. It says the equation of two circles are given there and there. Write down the centre and radius of each of the circles. So here we really need to use your log tables. Page 19, coordinate geometry, the circle. You are given an equation, x squared plus y squared plus 2gx plus 2fy plus c. And it says that the centre is minus g minus f and the radius is square root g squared plus f squared minus c. So what I'd recommend is going x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Centre is minus g minus f. And the radius is g squared plus f squared minus c. We know for the first one, for C1, 2g is equal to minus 6, g is equal to minus 3, minus g is equal to 3, and 2f is equal to minus 10, f is equal to minus 5, minus f is equal to 5. So the centre is 3, 5 for the first one. And the radius then for the first one is the square root of minus 3 squared plus minus 5 squared minus 29. 9 plus 25 minus 29 square root of 5. Square root 5 is the radius, and the other one, 2g is equal to minus 2, g is equal to minus 1, minus g is equal to 1, 2f is equal to minus 2, f is equal to minus 1, minus f is equal to 1. And the radius is going to be minus 1 squared plus minus 1 squared minus minus 43, so it's plus 43. Square root of 45. Square root of 45 works out to be 3 root 5, yeah. 3 root 5. So the centre is 1, 1. And the radius is 3 root 5. Prove that the circles are touching. Well, the circles are either overlapping, like so. They're either touching internally or touching externally. The interesting thing is to find the distance between centres. Centres. So 3, 5 and 1, 1. x1, y1, x2, y2. Distance between 2 points. x2 minus x1 squared plus y2 minus y1 squared. 1 minus 3 squared plus 1 minus 5 squared minus 2 squared plus minus 4 squared. 4 plus 16 square root of 20. Square root of 20 is 2 root 5. So they are touching internally. D is equal to or 1 minus or 2. 2 root 5 is equal to one of the radiuses, which is the big radius, 3 root 5, minus the little radius, which is root 5. 2 root 5 equals 2 root 5. And show you visually what that looks like. Big circle with the radius, and then small circle with the smaller radius. We know the distance between the centres is 2 root 5. We knew the big radius was 3 root 5, and the little radius was root 5. So they are touching internally like that. Verify that 4, 7 is the point that they have in common. So therefore, 4, 7 should be on both circles. And how do I know if it's on both circles? I'm just going to take a snip of this. So here's both our circles. So we're going to go 4 squared plus 7 squared minus 6 by 4 minus 10 by 7 plus 29 is equal to 0 for C1. 4 squared is 16 plus 49 minus 24 minus 70 plus 29 is equal to 0, and presumably 0 is equal to 0, but do just take your time, put it into your calculator, make sure you haven't made any mistakes. 29, 0 is equal to 0, therefore it's on it, fine. C2, you're getting 4 squared plus 7 squared minus 2 by 4 minus 2 by 7 minus 43 is equal to 0. 16 plus 49 minus 12 minus 14 minus 43 is equal to 0. Double check, 0 is equal to 0. 16 plus 49 minus 12 minus 14 minus 43. Whoop. 16 plus 49 minus 8. There we go. Prime example, minus 8. And that does make the difference. 0 does equal to 0 now. That's what I mean. Always good to check that you haven't made a mistake. As 4, 7 is on both circles, it is the point of contact. Perfect. Last question. Find the equation of the common tangent. This is really, really easy. What they want you to try and do is go the long way about it. You've just found this point. You know the centers. Could you find the slope of that line? If you could find the slope of that line, then you could find the slope of the perpendicular, because you just flip it upside down and change the sign. Then you know the point of contact. You could find the equation of the green line by using y minus y1 is equal to m by x minus x1. But we know the equation of both circles. Both circles are here. I'm going to copy that and bring it down. Copy. So to actually find the equation of the common tangent, it's easiest to just take the circles away from each other. So multiply the second one by minus 1, and it changes them all. So x squared minus x squared is 0, y squared minus y squared is 0, 6x minus 6x plus 2x is minus 4x. Minus 10y plus 2y is minus 8y. 29 plus 43 is 72. So plus 72 is equal to 0. 4x plus 8y minus 72 equals 0. Question done. Now I admit that you could simplify that a little bit further. So it's x plus 2y minus 72 divided by 4. It's 18, so minus 18 is equal to 0. Doesn't say to leave it in its simplest form or anything, so you could probably leave it like that, but always nice to simplify it a little bit further. Hopefully the video, or you didn't find that question too hard. Really quite nice question for a coordinate geometry circle. And hopefully you found the video useful.